Next speaker, Don White, measuring, monitoring, and verifying geological storage.
Hello from Ottawa. So I'm going to tell you a little bit about a project we've been working on for the last 4 years. Next slide. And you can skip the abstract. So if you peruse this list, you'll find one of your favorite NRCan scientists somewhere in that list, but there's the usual suspects. There are industry players, academia, and some international partners as well in this work. So the next slide, please. So the project we've been working on is a project called Aquastore, where we're looking at CO2 storage in a geological formation with a view to reducing CO2 emissions to the atmosphere. You can see it's located in the southeast corner of Saskatchewan. Next slide, please. And the industrial source of CO2 is one of SaskPower's coal-burning power plants located at Boundary Dam. You can also see the capture plant that was built there. Oops. And they started capturing CO2 in 2015, and to date they've captured about 2.5 million tons, and that's the equivalent of several 100,000 cars taken off the road if you're looking for how much CO2 reduction that is. Next slide, please. So from the GSC's point of view, the two things we wanted to study were methods for monitoring the CO2. Can you see where it is in the subsurface? And do you induce any seismicity with this process? The outcomes from the project were informing regulation and the development of standards that are currently being developed. Next slide, please. So this is a map of the site itself. On the right-hand side, you can see the power plant. The blue areas are the fly ash ponds. The red line is the CO2 pipeline that takes the CO2 from the plant over to the well site, which is the yellow derrick symbol. And the green dots are a permanent seismic array we installed to try and monitor where the CO2 is going in the underground. Next slide, please. One of the first things we did was a 3D seismic survey across the area. What that gives you is a three-dimensional cube showing the strata in the area. We then used that to site a well, which was drilled at 3,400 meters depth. And the reservoir where we're injecting the CO2 is at the base of the Phanerozoic cover. It's shown there in yellow. It's capped by a shale formation. And above that is a nice thick salt layer, the prairie evaporite. And it's about 150 meters thick and forms a seal that would impede any upward migration of CO2 if it were to leak from the reservoir. Next slide, please. So using the information from that drill hole, we built a geological model and ran some fluid flow simulations to get an idea how the CO2 is expected to spread and how large an area we would have to monitor. Next slide, please. So at the Aquastore site, we receive about 10% of the CO2 captured at the Boundary Dam power plant. And this is the cumulative amount of CO2 since 2015. And at the end of last year, they surpassed 200,000 tons injected. We've done 3 monitor surveys at 36, 102, and 141 kilotons. And I'll show you the results from those. Next slide, please. So these are the time-lapse seismic results. This is a horizontal slice through the 3D volume. The colored background you can ignore. What we're really interested here are the black and white images. And this shows how the CO2 plume is spreading over time during a period of about 3 years. And you can see from left to right, the main plume is increasing in size. Next slide, please. So now we're looking at vertical slices through that same volume. If you look on the vertical axis, you'll see the extent of the reservoir. It's approximately 200 meters thick. And again, we're looking at the 3 monitor surveys as compared to the pre-injection survey. And you can see that within the reservoir zone, the bright orange zone corresponds to the CO2 plume, which is spreading over time. Just as importantly, above the reservoir zone, we don't see any significant evidence for CO2 in that zone. Next slide, please. So as well as monitoring where the CO2 plume is, we wanted to look at possible induced seismicity associated with CO2 injection. And on this slide, you can see the boxes and symbols are a number of broadband seismograph stations, and then as well as 2 orthogonal lines of short period geophones that have been deployed at the site for this purpose. Next slide, please. This is a chart simply showing the monitoring that we have been doing. So we actually started back in 2013 to get some sort of baseline in terms of seismicity. This is a very stable area. There are very few earthquakes, but we wanted to establish that objectively before the start of CO2 injection. And you can see that monitoring has gone on continuously since 2013. Next slide, please. So the results of that are disappointing if you're a seismologist, but if you're the operator, it's good news. We haven't observed any induced seismicity at the site. Our estimates of sensitivity are that we should be able to detect anything of a magnitude 0 or less, and there's been no indication of any sort of activity. Next slide, please. So to summarize, I think we have shown that with a permanent installation, you can get good images of a CO2 plume, even at depths of 3.5 kilometers. We've shown the CO2 is in the reservoir and is behaving as expected. We don't see any evidence for CO2 leaking out of the reservoir. And we also have not seen any induced seismicity at the site. Next slide, please. If you have any follow-up questions, I'd be glad to answer them. You can contact me there, and I'll say thank you.
Thank you, Dan.